Hey guys, today I want to show you how you can simplify quotients of complex numbers. So let's do some examples. So let's suppose we have the following number. We're going to have 5 over 3i. Now how do you simplify this? Well, remember something about algebra. When you have, for example, let's say 10 over 3 times the square root of 2, what do you do to simplify this? You rationalize. We know I is also a radical. Just simplify, a complex number, minus the square root of minus 1. But it is also a square root. So that's exactly what we're going to do. We're going to rationalize, in this case, the denominator, and not multiplying by a conjugate, in this case, but rather by I. So we're going to multiply top and bottom by I. So now let's see what happens. We will get 5i over 3i squared. Now we know I squared, that's just simply minus 1, so we get 5 times I over minus 1 times 3, you would get minus 3. And this is our answer, or to some extent what you can do in order to simplify or change an expression that has a complex quotient. Now let me show you another example. Let's suppose we have the expression 3 over square root of 2x times I. How do you simplify this? Well, if you think about it, in the last problem, what we did was to multiply I and its coefficient by top and bottom. Now we're going to do the same thing here. Previously, the coefficient was 1. In this case, it's just simply square root of 2x. So we're going to do that. We're going to multiply it by this expression. So we would have the square root of 2x times I over the square root of 2x times I. Now let's distribute. This would give us 3 times the square root of 2x times I outside the radical. And now in this case, what we would get here, it would be square root of 2x squared times I squared. Now this goes to, that's the worst equal sign. So this goes to, we know the radical cancels out with the square, so we would get 3 times 2x times I over, square goes out with the radical, so you get 2x. Now we know I squared is equal to minus 1. Because of this, you square this, square this, the radical goes out. So you would get times minus 1. And now this would just simply be, same thing on top, times I over minus 2x. And this is the answer we're looking for simplifying the expression up there. Now let's do a different problem. Let's suppose we have 1 over 10 plus 2i. Now what do we do here? Well, in this case, we know this is a binomial of a complex number, of course, but it's a binomial. And this is a square root. What we can do is rationalize by multiplying by its conjugate, in this case of the denominator. Same thing as we would do in the real numbers. So we would get, multiply on top by conjugate, of course. Remember, you gotta switch the sign. So you get 10 minus 2i divided by same thing. Now you can distribute, so you would get on top 10 minus 2i over, now let's distribute this, so we would get 100 times minus 20 times, I'm sorry, now forget the times, just 100 minus 20. And now let's multiply this one by this, so we would get plus 20i, and now we would get minus 4i squared. Now let's keep simplifying this. So we would get, the top remains the same, so we get 10 minus 2i. Now these two terms, they're positive and negative, they cancel out, and we know this guy right here, it would go as minus 4 times the square of I is equal to minus 1, so we get minus 4 times minus 1, which is just simply 4. So we get plus 4 So we get 100 plus 4 on the bottom. 100 plus 4. Remember, these two terms, they went out, and this was minus 4 times minus 1, positive 4. We get this, and we would finally get 10. That's supposed to be a 10. Like, that's so gross. This is supposed to be a 10. 10 minus 2i divided by 104. Cool. And now we could simplify this. Just take out 2, so we will get 2 times 5 minus I over half of that would be 52. Just, yeah, 2 times 52. Yeah, we're just going to go straight up with the 2 times 52. Can we still simplify anything? No, just that would be all. So your final answer would be 5 minus I over 52. And this is how you simplify this expression up here. Now let's go with a more complicated example. So now let's suppose we have the expression 10x plus 3i divided by 3x plus, actually minus, just so we switch the things, minus 4i. Now what do we do here? Once again, this is a binomial, and we gotta simplify, or we gotta rationalize in this case. So now you might be wondering, well, should we choose to rationalize the conjugate or multiply by the conjugate of numerator or denominator? In this case, the most common method or approach is multiplying by the conjugate of that denominator. Okay, if you have I both in the numerator and denominator, you would normally use the denominator to multiply by. Okay, so now let's do that. So let's see how this would go. We'd have 3x plus 4i over, let me rewrite this so we use a bit better space. That looks so bad. 3x plus 4i. Now let's FOIL everything. So we would get 30x squared on top. Now plus 40xi. 40x times I. These two done. And now minus plus 3. I'm sorry. Plus 9i as 9x. The same thing as this. Just you can switch the order however you want. I mean, actually, the right notation would be to place the x first, since like in hierarchy, the real numbers should go before than the complex numbers. It's the same thing as if you have higher degree variables, you place them before. You place them before the smaller degree variables, and we would get 3 times this one times that one, and we would get finally plus 12i squared. We can simplify that later on. And now let's do bottom. We would get 9x squared. 9x squared plus 12x times I minus 12x times I. And now we get minus 16i squared. Now let's see how we can simplify this. On this side, we would get, can we do anything else? No. So we get 30, this is equal to 30x squared plus 49x times I. And now we know in this case, this would be I squared is minus 1, so we get minus 12 here. Over these two terms, they have opposite signs, so they cancel out. Over 9x squared. 9x squared. Now in this case, once again, we get minus 1i squared. So we get positive 16. Positive 16, cool. And this would be our final value. Let me see if we can do something else. 7, no, 35. No, I don't think we can simplify anything else. No, apparently we cannot simplify anything else. I believe so. So is 49 multiple of 3? 3 times, no, I believe not. Yeah, if my simple, most basic maths are not incorrect, the 49 is not a multiple of 3, so it should be good to go, yeah. And well, not even 4, yeah, no, never mind, yeah. So this would be our final value in this case. So I hope you guys enjoyed this video, and see you in the following one.